start section 4.5, which is going to be all about this process called completing the square. And what completing the square is going to be one of the first of a handful of methods that we have to solve quadratic equations, specifically when they do not factor. So our primary method of solving is factoring using the multiply to c and add to b method, or the Xbox method of factoring. We'll have about two different methods or so that will allow us to solve equations when they don't factor. The first is completing the square. So we have one learning target, which is I can use the process of completing the square to solve quadratic equations and recognize when a solution will be complex. Okay, so we'll see a handful of complex solutions, which will be similar to the type of things that we got in 4.4, involving I. Anytime you have I, you're going to have a complex number. Okay, so before we actually learn how to complete the square, let's go ahead and kind of see why this might be convenient. So let's say I have something like this, and I am trying to solve it. X squared minus 16x plus 64. As I look at this problem here, I can set this equal to 0 and try to factor. That may or may not work, but I am recognizing something here. I'm recognizing that this here, okay, has 3 terms, and the a value is 1, multiply to c and add to b. Well, the two numbers that multiply to positive 64 yet add to negative 16 is negative 8 and negative 8. So I actually know that this factors into x minus 8 times x minus 8. And that's equal to 100. Okay. Furthermore, x minus 8 times x minus 8 actually condenses down into x minus 8 squared. For the same reason, if I said x times x, most of you would be able to tell me that that is x squared. So if x times x is x squared, that means x minus 8 times x minus 8, well, that's x minus 8 squared. Now, this is really convenient for me because we've kind of seen this in the past. What is going to undo squaring? Well, the operation that's going to undo that is square rooting. So now I'm just going to go ahead and square root each side. Okay, so now I'm square rooting each side, and well, what happens here? Well, if I square root a perfect square, because this is x minus 8 squared, making it a perfect square, the square root symbol and the squaring symbol, they just kind of undo each other. They're inverse operations. So squaring and square rooting are inverse operations. They undo each other. All that's left over is x minus 8. Okay, now what about the right side here? I can't recall if this is the first time we've seen square root of 100. Well, we know that it's 10. Most of you are going to be able to tell me 10 because 10 times 10 is 100. But we also have like a second answer. We have 10 times 10 is 100, but also negative 10 times negative 10. We can even see that here. If I can get that out of the glare. Negative 10 times negative 10 is also 100. So we're going to, I can't remember if this is the first time. We're actually going to see this as plus or minus 10, meaning that I have two answers there, positive 10 and negative 10. Okay, and so then here I can just continue to solve. I would have to add 8 to each side. Okay, so I'm going to go ahead and finish my work up here. And we are going to get x is equal to 8 plus or minus 10. So what does 8 plus or minus 10 mean? Well, it quite literally means 8 plus 10 or 8 minus 10. So we have two answers again. X is equal to 8 plus 10, okay, which we know that that is equal to 18. Or the other answer is x is equal to 8 minus 10, which that is going to be equal to negative 2. Okay, so these two values plugged into this equation are going to give me 100. So let's go ahead and see make sure that's correct. You know, I can go ahead and I'm just going to replace these x values I got. 18 squared minus 16 times 18 plus 64. Well, that's 100. Okay, and then the other number I got was negative 2. So I can go negative 2 squared minus 16 times negative 2 plus 64. And I also get 100. So you can see that these balance this equation out perfectly. Okay. And the reason why this strategy worked is because if you recall from section 4.3, x squared minus 16x plus 64 is a perfect square trinomial, meaning that it simplifies into one binomial itself squared. It's a perfect square trinomial. Okay, so what we're going to do is we are going to spend some time now figuring out, like, what does this value down here have to be so that the trinomial itself becomes a perfect square trinomial, because that is what we're looking to try to achieve, is to create perfect square trinomials so they factor into something nice like this, and then we can just square root each side. So when I look at example 1, I want to find the c value here that's just going to make this a perfect square trinomial. So in my class, we grade on that rubric here, 4 to 0. Really, you're going to have to be able to complete the square, one of the things I'm going to look at to see that I need to see out of you is that you have the appropriate c value added in. And we'll see how that looks out more. But really, let's look at this pattern. Well, what is the relationship between 16 and 64 and then this 8? Because that 8 is pretty crucial. Okay, because they all factor down into 8 because they multiplied to 64 and added to negative 16. Well, this number squared is 64, and this number here divided by or times 2 is negative 16. So that means I'm looking for the number that is half of this number and then the square root of that number. Okay, so basically it's just going to follow a formula. Okay, so for completing the square, our c value is going to equal the b value divided by 2, that whole thing squared. Okay, so if we find our b value, we can divide it by 2 and square it, and that will give me my appropriate c value. Okay, let's go ahead and check that. Well, what is my b value? Well, my b value here is 8. Okay, so if I want the appropriate c value, I am just going to go ahead and plug that into this formula. So here I have 8 divided by 2 squared. Okay. So 8 divided by 2 is 4, so this now becomes 4 squared. 4 squared is 16. Okay, so that means my c value here has to be 16. Let's go ahead and check and make sure that worked. Okay, so then we can we believe our c value is 16. Now, if I want to go ahead and see if this works, let's just factor this. If it factors correctly, it should be one term squared like we got up here. So this is a 3-term. It's a trinomial. And my a value is 1. That means I'm looking for the numbers that are going to multiply to 16 and add to 8. So what numbers are going to multiply to 16 and add to 8? 4 and 4. So this is going to factor into x minus 4 or plus 4 times x plus 4, which means it does factor into just x plus 4 squared. So this actually means that it worked out perfectly, the exact way that we wanted it to. Okay. Notice, folks, so sometimes you know, if you're catching on to these patterns that are happening here, you don't actually have to go through the work of factoring this if you select the proper b value, because it's x plus 4. It's not a coincidence that b divided by 2 is kind of the two parts that it factors into. So b divided by 2 is 4, 4, and 4 is kind of the key factoring method. Okay, we're going to kind of see that again in example 2. So in example 2, I know that my b value is negative 18. Okay, so then I want to find the c value that's going to make this a perfect square trinomial. So I plug it into the formula. Okay, b divided by 2, quantity squared. All right, and then I'm going to go b divided by 2 is negative 9. Negative 9 squared is 81. Okay, now again, notice how even though this inside is negative, I have to put this into the calculator appropriately. I can't remind you of this enough because I know that a lot of you are going to do this And this is just wrong. That gives you negative 81, okay? Negative, as opposed to negative 9. It's got to keep that negative with the 9, as opposed to this mode will square the 9 and then take the opposite of it. This one is going to take negative 9 times negative 9. Okay, let's go ahead and check it. This part is not necessarily required of you, but it's very good practice. I've already screwed that up. Again, it's not required of anybody, but this is just good practice to see if our C value we're selecting is appropriate. Okay, so I'm looking for the numbers that multiply to 81 and add to negative 18 because my A value is 1. That's negative 9. So we're going to get x minus 9 times x minus 9, and that factors into x minus 9 squared. And as you can see, that ended up working out. And again, it factors into whatever b divided by 2 is. As you can see, negative 9 here, and we have negative 9 here. Okay, so I think right now is a good time and opportunity for each of you to try and find that appropriate C value that makes each of these a perfect square trinomial on your own. So go ahead, pause the video, try A and B on your own, and then go ahead and check it with me right now. So I'm assuming you've already done that. So my B value here is negative 14. Okay, so negative 14, so that means my C value is going to be negative 14 divided by 2 squared. That means my C value is negative 7 squared, and negative 7 squared is 49. Okay, here my B value is 22. That means my C value is going to be positive 22 divided by 2 squared. And then this is going to be 11 squared. And 11 squared is 121. So again, what we're doing right now is not completing the square, but this is a very, very key pivotal part of completing the square. Okay, let's move to the next page. Let's actually go ahead and complete the square. But first, let's talk about why this problem here is often very beneficial to us. It's often very beneficial to us because if we look at this problem here, x squared plus 20x plus 11. You know, if we didn't know that we had to complete the square here due to the instructions, we would need to kind of try to recognize that this problem is not factorable. X squared plus 20x plus 11. We would be looking for numbers that multiply to 11 and add to 20. Well, there's only one whole number combination of numbers that multiply to 11, and that's 11 and 1, and those add to 12. So this is not factorable. So really the first thing you want to do is normally when you're factoring to solve, you want to set it equal to 0. In this one, you want to move your C value to the opposite side. So you want your terms here, and you want your constant terms, your C value terms, you want to shift that over to the opposite side. So I am going to go ahead and minus 11 to get x squared plus 20x is equal to negative 11. Okay, 0 minus 11 is negative 11. Okay, and then this is where that b divided by 2 term, that special term, comes in. Because now what I want to do is I want to try to make this a perfect square trinomial, just like we did on the previous page. And then when I do that, it will factor into one nice term squared, and we can square root each side to solve. Okay, so what is that term? That term for us is going to be 20 divided by 2 squared. Okay, so 20 divided by 2 is 10. 10 squared is 100. So what does that mean for us? That means I need to add 100 to each side of the equal sign. Now, and the reason why I have to add it to each side is because I want to add 100 here to make this a perfect square trinomial. But you can't blindly add 100 to one side, but not the other, because then that equation becomes out of balance. So we're going to have to add that 100 to the opposite side as well to keep our equation in balance. Okay, so again, I need, when you're thinking about how I'm going to grade this, if this C value is incorrect, you're not even capable of getting a 3. This is like one of the first barriers to cross. In order to get to the 3, you can't get to a 4, which is 100%, without getting to a 3. So now that I have this here set up as a perfect square trinomial, I have this set up as a perfect square trinomial. Now I can factor this. Even though that this is not set equal to 0, this is easily factorable. Okay, so we're looking for numbers that multiply to 100 and add to 20. So multiply to 100, add to 20, that's 10 and 10. And then I believe this is 89. I'm going to double check that. I don't want to go through this whole problem and find out I did that one wrong. Okay, good. All right, so then now I'm looking at this and saying, hey, x plus 10 times x plus 10, well, that's pretty easy. That's x plus 10 squared. Okay, and this is the reason why we complete the square. This problem was unfactorable to begin with, so it was tough. So we kind of manipulated it so it is factorable, specifically in a way that we can just take the square root of each side, because what's going to undo this square symbol is square rooting. So let's go ahead and do that. Okay, so this turns into x plus 10 is equal to, well, we want to see if that simplifies. So 89, it's not going to divide by 4. It's not going to divide by. You want to check. You always want to try to simplify this as we did in the previous section. Yeah, I don't think this simplifies. So this is going to be the positive and negative square root of 89. Okay. Then I just have to get x by itself, so I'm going to go ahead and subtract 10. To get x is equal to negative 10 plus or minus the square root of 89. Okay, now this is a pretty odd-looking answer, but that's just because this original problem doesn't factor because it probably doesn't cross the x-axis at a very nice, neat value. Like if we were to graph this, we would see that it crosses at a very odd looking value. Not at like 3 or 2, but, you know, at negative 10 plus the square root of 89 and negative 10 minus the square root of 89. So for myself here, this is just the end of the answer, or the end of the problem. You don't need to split it up. If this is not going to be a nice, neat number, then this is what your answer is going to look like. Negative 10 plus or minus the square root of 89. Okay. We could go ahead and try to plug that in if we really wanted to and see that it works. So here I have negative 10 plus the square root of 89 squared plus 20 times negative 10 plus the square root of 89. And then plus 11, and it gives me 0. So as you can see, this is just the exact answer. We could go ahead and get decimal approximations, but for myself, I like the exact answer because as you can see, I'm replacing this whole value with x, so negative 10 plus the square root of 89 squared times 20 times negative 10 plus the square root of 89 and then plus 11. And if I did this exact same thing, but went ahead and did minus instead, because I did negative 10 plus and now I'm doing minus, we should get the exact same thing. Well, I'm not really sure why I came up with this, but this is 1 times 10 to the negative 11th. That would round to 0, so I'm not 100% sure why it's coming up with that. I'll have to do some looking into that. Weird. Either way, that's the part that balances the equation out to 0. Okay. So what about if we have a problem like number 4? Number 4 is a little bit odd because the a value isn't 1, so it's not quite as neat. So what you need to do is you need to divide your problem. Divide your equation. So a is equal to 1. Okay, I'm sure there's other methods that you can try to choose to do to do this problem when a doesn't equal 1, but we're just going to go ahead and go under the assumption that you cannot do these problems unless your a value equals 1. So that means we're going to have to do a little division here. Okay, so as I'm looking at this here, I have 4x squared minus 16x plus 20. That's equal to 0. So what am I going to have to divide this by so that my a value becomes 1? Well, this 4x squared, I'm going to need to divide by 4. That's what's going to make it 1. So 4x squared divided by 4 is x squared. Negative 16x divided by 4 is negative 4x. And 20 divided by 4 is 5. Okay, so again, we can even look at this and say what numbers multiply to 5 and add to negative 4. Well, it's either going to be positive 5 and positive 1, which doesn't add to negative 4, or negative 5 and negative 1, which again does not add to negative 4. So this problem's unfactorable. Okay, it's unfactorable, so that means we are going to need to complete the square. We're going to start completing the square by removing the c value from the side of the equation. Okay, then we want to identify that c value that I'm going to have to plug in. Use your c value from here after you've divided. So mine is going to be negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So we got to add 4 to each side. Okay. So now I get this here, which can be factored. I'm looking for numbers that multiply to 4 and add to negative 4, which is negative 2 and negative 2. And we already know that because b divided by 2 is negative 2, so we kind of already know what that's going to factor into. And negative 5 plus 4 is negative 1. Okay, so now I need to undo that square symbol, and I'm going to do that by square rooting. Okay. All right, hopefully some people are identifying that we're taking the square root of a negative number, and that's going to normally, in previous lessons, this wouldn't be something you can really do. It will give you an error in your calculator, but as we learned in the previous section that we have tools now to give us solutions to this. They're just complex solutions. So what's going to happen? We're going to get x minus 2 is equal to the square root of negative 1, if we recall from the previous section, is I. Okay, then I can go ahead and just add 2 to each side. So x is equal to 2 plus or minus I. Okay, and this is going to be my answer. This is also going to be an answer that's not going to be easily plugged into our calculator. We could go ahead and plug it in and solve. It would take quite a bit of work, which, if anybody's that interested, you can seek me out and we can go ahead and plug it in and see why it does work indeed. Okay, now let's think about this problem compared to the first one. Okay, this is 2 real solutions. Okay, because these are actual numbers. I can find where this parabola crosses the x-axis at these values. Okay, I can find those values on the number line. They're not going to be easily found because they're really wonky, weird decimals, but I could find those. Those are real numbers, as opposed to this has 2 complex solutions. And essentially what this means is I cannot find 2 plus I or 2 minus I on the number line. Mathematically, you plug them in, they're going to make it equal to 0. But this parabola here, if I were to graph this, it just does not cross the x-axis. So it technically has no real way of finding the it has no real way of crossing the x-axis, but we found a way to make it happen. So I just graphed this. As you can see right here, I just graphed this parabola here. Okay, and we want it equal to 0. And as you can see, the y value never actually equals 0. So it doesn't actually ever cross this, but we have complex solutions that allow us to find solutions to like kind of make it equal 0. And that's kind of like the whole point of complex solutions. Okay, so just a few things to remember. One, if your a value is not equal to 1, you need to make it equal to 1 by dividing by whatever the a value is. And then you need to remove the c value and then add in your new appropriate c value that makes it a perfect square trinomial. I think right now is a fantastic time to pause the video and try C and D on your own. Okay, and then check it with me when you are done. So I'm assuming that you've already tried this one. You're checking to see how you did. So let's go ahead and try or do these together now. Okay, I need to divide by 6 because I need my a value to equal 1. So I get x squared, and I do not know what 72 divided by 6 is off the top of my head. I do, it's 12. I realized that after I started doing it. Okay, I definitely don't know what 222 divided by 12 or 6 is. 37. Okay. So here I get x squared plus 12x is equal to 37. Okay, good start. So now I need to remove that c value. I'm going to do that by subtracting 37. So I'm going to get x squared plus 12x. I'm going to leave a little gap here for me to add in my new c value. Let's figure out what our new c value is. Again, don't use your c value from the 72. Use it after you've divided. So for us, it is going to be 12 divided by 2 squared, which is 12 divided by 2 is 6. 6 squared is 36. Okay, so I got to add in a 36 here. Okay, and so then now I need to factor this. Numbers that multiply to 36 and add to 12 are 6 and 6, which is no surprise because b divided by 2 is 6. So that really gives us a way that this is going to be x plus 6 is equal to negative 1. Okay, I need to undo the square root or the square symbol by square rooting. Okay, that's just going to completely undo that. So I'm going to get x plus 6 is equal to plus or minus I. If you refer back to section 4.4, the square root of negative 1's actual definition is I. Then I can go ahead and solve for x by subtracting 6. So I get negative 6 plus or minus I. That's my solution. Now let's go ahead and try to identify, are these real solutions or these complex? Folks, if it ever involves I, it's a complex solution. So we have 2 complex solutions. Okay, 2 complex solutions because we're going to have, the first one is negative 6 plus I. The second one is negative 6 minus I. Okay, so then now here I'm looking at letter D. This letter D is actually kind of nice. It kind of already did a lot of work for us. And the work that it did for us is it just completely removed the C value already for us. It's because it's not on this side. So that's actually pretty convenient. So we can go ahead and figure out what our C value is. Our C value is going to be negative 24 divided by 2 squared. Negative 24 divided by 2 is negative 12. Negative 12 squared is 144. So we know we're going to have to add in 144 to each side. So let's go ahead and do that. Okay, and negative 167 plus 144. Okay, so then again, b divided by 2 is negative 12. So we know that this is going to factor into x minus 12 times x minus 12. Or, again, multiplies to 144, adds to negative 24 is negative 12 and negative 12. And then negative 167 plus 144, negative 23. Okay, Then I can square root each side. Go ahead and get this. And that gives me x minus 12 is equal to, well, the square root of negative 23. So we want to check if perfect squares divide into that. So we're going to check 1. That doesn't do anything. 4. It doesn't. 9 does not divide into that. 16 does not divide into that. And we're already, the next one would be 25. So it is negative. So we got to kind of pull that negative sign out and get plus or minus I square roots of 23. Then I have to get the x by itself by adding 12 to each side. All right, this is my final answer. And again, this would be complex solutions. Okay, it's two complex solutions because the first is going to be 12 plus I square roots of 23. The second one is going to be 12 minus I square roots of 23. Okay. All right, just two more examples. Let's do example 5 and then E, and then I will let you all be on your way. Okay, what if we have a weirdo problem like this, right? It's not even set up in like kind of our traditional ax squared plus bx plus c form. It's just in some other form. Well, we have a number right outside of parentheses, so we can actually just try to convert this into that form. Okay, so let's go ahead and distribute here. And then we get 6x squared plus 12x is equal to negative 60. Now it's in our more traditional ax squared plus bx, even though the c value has been moved to the other side. So we still need to get the a value as 1. So we're going to divide by 6. So we get x squared plus 2x is equal to negative 10. And then my new c value here is going to be 2 over 2 divided by 2 squared. 2 divided by 2 is 1. 1 squared is 1. So we're going to add 1 to each side. All right. So then here, this is going to factor into x plus 1 times x plus 1, or x plus 1 squared. And this is going to be negative 9. All right. So as you can see, this problem, all I'm doing is adding one extra step. I'm adding an extra level of complexity to it. But it's really not adding too much more. This is, distributing is something that we should know how to do at this point. And then this turns into just one of the problems we had on the previous page. Got to get the a value equal to 1, add in your special c value, okay, and then now we can square root. So then I'm going to get x plus 1 is equal to the square root of negative 9. Now that is a perfect square. It is 3i, so this is going to be a plus or minus 3i, so we already know we're going to have a complex solution. Square root of the negative 1 here is I, the square root of 9 is 3, so it's just 3i. Then I can subtract 1. All right, so this has two complex solutions again. Two complex solutions, negative 1 plus 3i, negative 1 minus 3i. Okay, E is virtually the same thing, different numbers. Otherwise, process is the same. So I'm going to go ahead and let you pause the video and try this one on your own and check it with me right now. Assuming that you've already done this and you're here to check your work, we're going to go ahead and distribute 2x to each side. So here 2x times x is 2x squared. 2x times negative 2 is negative 4x, and that's equal to negative 202. Okay, we need to get the a value equal to 1. And my a value currently is 2, so we're going to divide by 2 here. So we're going to get x squared minus 2x is equal to negative 101. Okay, now we have to find our special c value, which is going to be negative 2 divided by 2 squared, which is also 1. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So we have to add 1 to each side. Okay, this is going to factor into x minus 1 squared. This is going to be negative 100. Okay, so x minus 1 squared, because negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. Okay, and again, our b value divided by 2 is ending up what it's going to be factoring into. Then I can go ahead and take the square root of each side. So I get x minus 1 is equal to, and then this one, the square root of 100 is 10. The square root of the sneaky negative 1 out here is going to be I, so this is going to be plus or minus 10I. Then I can add 1 to each side. Okay, my answer involves I, so this is again going to be 2 complex solutions. All right. Otherwise, folks, that is the end of this lesson, 4.5, completing the square. Our overall, the big concept you need to know is how to make it a perfect square trinomial, which I've had in red in every problem, is by adding in that special c value. Otherwise, go ahead and move on to the homework, and I will see you next time for 4.6, which I believe is the quadratic formula. See you then.